Hello everyone, this is Mr. Regner and this is our Chapter 1 study guide. The purpose of this video is that you can use it to review for Chapter 1. With that in mind, let's think about what's in Chapter 1. So far we've learned about the order of operations, we've learned about exponents, think about PEMDAS, prime factorization and all those factor trees, the greatest common factor or GCF, and of course least common multiple. So these are the main things to know about Chapter 1, and one of the greatest tools that we have would be our study guide. This is the Chapter 1 study guide, and what I'm going to do in this video is just kind of go through each question, sort of explaining it and answering it on the study guide. Now keep in mind that our study guide is very, very close to the look and the feel of our test. So if you do well in your study guide, you should, in theory, do very well on your test. So let's take a look here, starting off with number 1. It says write 7 times 7 times 7 times 7 as a power. And as I look at that, I have 7 times 7 times 7 times 7. I have 4 7s. So I know my base is going to be 7. That's the number that is being repeated. My exponent is the number of times that it's repeated, and that is 4. So I've written 7 to the 4th power. I'm done with number 1. That was pretty easy. Let me move on to number 2. It says find the value of 9 squared. Well, I know that 9 squared is going to be 9 repeated 2 times, or 9 times 9. That's probably a fact that you should know, and that's 81. So my answer here is 81. That was pretty easy. Let me move on now to number 3. Now for 3 and 4, I'm going to determine whether the number is a perfect square. Remember that a perfect square is a number that is the answer to a number squared. All right, so I can make a small list over here. I'll say like 2 squared, that equals 4. 3 squared, that equals 9. 4 squared, that equals 16. 5 squared equals 25. 6 squared equals 36. 7 squared equals 49. 8 squared equals 64. 9 squared equals 81, and so on and so on. So when I look here, I have 48. 48 is not one of my perfect squares, so I'm going to say no. And then I have 64. 64 is a perfect square. That's 8 squared equals 64, so I'm going to say yes. Hey, I've got the first 4 done, and I'm not even sweating yet. Let me go ahead and take a look here at numbers 5 and 6. Scrolling down on my page, it says use the order of operations to evaluate. Perfect. So what I'm going to do is I'm going to make my Dorito chip, just following the order of operations. So parentheses first, 6 plus 4. I'm going to rewrite this now, and you'll notice that I have 6 plus 4, which is 10. That's going to be times, I have my brackets, 18 minus 2 plus 12, like that. I rewrite the whole thing just so that I can go step by step. The next thing I would do is, once again, the parentheses here in my brackets. So that's 18 minus 2 plus 12. Well, that's 14. So now I have my brackets to deal with, 18 minus 14. So that's 10 times 4. And now I have to multiply. 10 times 4 is 40. So my answer is 40. And take a look at my special Dorito chip here. I've solved that by following PEMDAS, or the order of operations. Let's move on to number 6. Once again, I want to do the order of operations, parentheses first. So 11 minus 4. 11 minus 4 is 7, so that's 7 times 7 minus 6 squared. Keep in mind, if I have a number next to parentheses like that, it just means multiply. Next, I'm going to use the exponents, 6 squared. Remember, that's 6 times 6, which is 36. So 7 times 7 minus 36. Next, I need to multiply based on order of operations. 7 times 7 is 49. And now I have 49 minus 36. If you need to break that off to the side and do that, you certainly can. And I'm going to do that just so I can show again here what that might look like if you were solving it off to the side. 9 minus 6, now this is easy stuff, right? 4 minus 3, 13. So I come up with my answer of 13. And look at that Dorito chip. Beautiful, beautiful stuff. Let me move on now to number 7. Number 7 says find the GFC of the numbers 18 and 36. Remember, GFC means greatest common factor. So I'm going to write out my factor trees, because that's what I should do every time I'm thinking GFC or creating prime factorization. So 18 breaks down into 2 times 9. 9 breaks down into 3 times 3. So the prime factorization for 18 is 2 times 3 times 3. And then 36, that'll break down into 6 times 6, and each of those 6's is 2 times 3. 2 times 3 are obviously prime, and my 6's would be composite. So 36 is equal to 2 times 2 times 3 times 3. So next, if I'm finding GFC, GCF, I need to circle all of my common numbers. There's a 2 there, there's a 3 there, and another 3 there. This lonely 2 here doesn't have a match. Sorry. So that means the greatest common factor between 18 and 36 is going to be 2 times 3 times 3, because I just pull one number from each of those. So 2 times 3 times 3. Let me break that down. 2 times 3, well, that's 6. 6 times 3, that's 18. So the greatest common factor is really 18. Moving on to number 8. Now, number 8 is kind of similar, but the language looks strange maybe. It says, what is the greatest common divisor of 12, 24, and 48? Keep this in mind. When I say divisor, what I'm really thinking of is a number that I could divide into. If I reverse that division problem, it becomes a factor. So I could think the greatest common factor. And it's the same deal. So once again, I'm going to make some factor trees here. I have 12, 24, and 48. There we go. So 12 breaks down to 2 times 6, and 6 is 2 times 3. And then 24 breaks down into, well, there's a lot of ways I could do it. I'll go 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. And then 48, again, a lot of ways I could break that down. I'm going to do 8 times 6. 6 is 2 times 3, 8 is 2 times 4, and 4 is 2 times 2. So boy, we've got a lot of stuff going on here. We want to make sure we keep it all straight and organized. So I'm going to write them out here. 12 equals 2 times 2 times 3. And 24 equals 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. And 48 equals, let's get this all straight, 2 times 2 times 2 times 2 times 3. 2 times 2 times 2 times 2. Let me double check. 2 times 2 times 2 times 2 times 3. Okay. So now I'm going to circle all of my pairs, or in this case, trios. I have a group of 2, a group of 2. Here I have a group of 3. So I'm going to take one of each of these numbers, 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So the greatest common factor is 12. So remember, don't get confused by that language, greatest common divisor. It's really just a factor. So if 12 is my answer, let me look at my options. 9, 12, 18, or 27. It's going to be letter B, 12. All right, so a multiple choice question, but clearly we still need to show some work there. That's page 1 of our study guide, and coincidentally also page 1 of our test. Moving on now to number 9. Find the LCM of the numbers 4 and 6. Now these numbers are pretty small, and it's probably easy for me just to list them out in a list of multiples, finding the common multiple, or the least common multiple, I should say. So let me do that. I have 4 and I have 6. So I'm just going to kind of think of this. If I need to, I can even go times 1, times 2, times 3, times 4, times 5, times 6, and keep on going. So 1 times 4 is 4. 2 times 4 is 8. 3 times 4, 12. 4 times 4, 16. 4 times 5, 20. I could keep on going and going and going. 4 times 6, I'll go one more time, I guess, is 24. Then I'll do the same for 6. 6 times 1 is 6. 6 times 2 is 12. And look at that. Ding, ding, ding. I've got myself a 12 and a 12. That is the least common multiple for 4 and 6. So I'm going to say LCM equals 12. Turns out I did a little more work here with the 4's than I needed to, but that's okay. That's LCM, that's number 9. Moving on, number 10. This one may seem kind of tricky for you at first glance, but trust me, it's not too difficult. I'm sure you can all do it. So we want to figure out which expressions below A, B, or C have the same value as 12 squared. Choose all that apply. So the first thing I want to think about is this 12 squared. That means 12, oops, if I can write, 12 times 12. If you know that fact, excellent. Otherwise, you may have to do a little bit of math to figure it out, but it's 144. So I want to solve each of these, A, B, and C, and see if any of them equal 144. So let me start with letter A. It's 4 to the third power plus 3 to the fourth power. Yikes. Those exponents are kind of getting me a little bit frightened here, but I should just not be frightened. Okay, so I'm going to take and do 4 to the third power first. I'll say 4 times 4 times 4. I'm going to group those together in parentheses just to kind of get myself started. So 4 times 4, that would be 16. 16 times 4, gee, I don't know what that is, but watch me do some math here on the side. 16 times 4. 4 times 6 is 24. 4 times 1 is 4, plus 2 is 6. So it turns out this is 64. I'm going to add that with 3 to the fourth power. That's 3 repeated 4 times. So 3 times 3, well, that's 9. 9 times 3, that's 27. 27 times 3, gee, I don't know. So watch what I do. 27 times 3. 3 times 7 is 21. 3 times 2 is 6, plus 2 is 8. That's 81. That might have been a math fact some of you knew. Okay, so now I have 64 plus 81. Again, it may be weird to look at it this way, so feel free to write it out kind of the normal way that you would. 81 plus 64. 4 plus 1 is 5. 8 plus 6 is going to be 14. That's 145. So right away I know that's not 144. Cross off A. Let me move on now to letter B. I might want to put a little line here, actually, just for myself, so I can kind of keep these things straight. Again, this is also a good point for me to make here. You can always use an extra sheet of paper. If you don't have enough room to work, extra sheet of paper is always welcome. So I have 12 times 3 squared plus 6 squared. Well, I want to do my exponents first, or actually my parentheses first, and since this is technically really in the parentheses, I'll do that first. It's an exponent. 3 squared. I should know that means 3 times 3, which is 9. So that means 12 times 9 plus 6 squared. I'll take care of that other exponent now, 6 squared. That means 6 times 6. So 12 times 9 plus 6 times 6, which is 36. Next, I need to multiply 12 times 9. If you know your 12 facts, you probably know this fact already. I'm going to work it out on paper here just to show you how that can be done. 9 times 2 is 18. 9 times 1 is 9, plus 1 is 10, and that's 108. So some of you might be thinking, yeah, I knew that. And you maybe did. Okay, so we have 108 plus 36. Again, I'm going to show this just for the people that maybe look at it that way and are not sure what to do. So I have 108 plus 36. 8 plus 6 gives me 14. 3 plus 1 is 4. And 1 is 1. So my answer here is 144. It looks like B is indeed equal to 12 squared, or 144. Let me go ahead and answer letter C. Again, 2 exponents. I'll start with the first one. I get 13 squared, so right off the bat, yikes, I don't know what that is. Watch what I do. 13 times 13. That's what 13 squared is. 3 times 3 is 9. 3 times 1 is 3. Add my placeholder 0. 1 times 3 is 3. 1 times 1 is 1. Now I'm adding. 9 plus 0 is 9. 3 plus 3 is 6. And 1 plus nothing is 1. So my answer there is 169 minus 5 squared. Next, I'll take care of 5 squared. Much easier. 5 times 5, 25. So that's 169 minus 25. Again, I always recommend setting this up in a way that makes you comfortable. And for me, personally, I look at that, kind of listed that way. I have to set it up this way to help myself see it. So 9 minus 5 leaves me with 4. 6 minus 2 leaves me with 4. 1 minus 0 leaves me with 1. So my answer here is 144. So I know letter C is also equal to 12 squared. So when you get to number 10, clearly a lot of work going on. You're solving 3 problems, but really almost a 4th problem up here. So you want to make sure you're taking your time and answering those correctly by following PEMDAS, or the order of operations. Moving on to number 11. Number 11 says, write the prime factorization of 54 showing all supporting work. Hey, that's easy stuff. I'm just going to make a factor tree for 54. So there's a lot of ways I could go with 54. I'm going to maybe go 27 times 2. You might say, why did you do that? That's just the route I took. You could clearly come up with different factors there, and it's okay. For 27, I'll say 3 times 9. 3 being prime, 9 being composite. 9 breaks down into 3 times 3. So the prime factorization of 54, I could say 54 equals 2 times 3 times 3 times 3. Now it's also possible for us to write this with an exponent and say 2 times 3 to the 3rd power. Again, we just list them in numerical order. Pretty simple. We just use a factor tree. Number 12. Many people will look at number 12 and think, it's impossible. I can't do it. We're looking at this expression, and it's going to be equal to 7 to the 6th power. Let me show you how this works, because it's going to be very, very easy once you know how. So I'm going to write this out just as it's written. 7 times 7 to the 3rd power times 49. And that's all going to be equal to 7 to the 6th power. So I want you to think about 7 times 7 to the 3rd power. 7 to the 3rd power is 7 times 7 times 7. What would 7 times 7 times 7 times 7 be? I could just combine those, and it would be 7 to the 4th power. So that's 7 to the 4th power times 49. How is that going to be equal to 7 to the 6th power? Well, let's think about 49 for a moment. You'll probably recognize that as a perfect square. 7 squared equals 49. So watch me just change this into 7 squared. So now I have 7 to the 4th power times 7 to the 2nd power. How is that all going to equal 7 to the 6th power? Well, I have 7 times 7 times 7 times 7. That's what 7 to the 4th power is. And then I have 7 times 7. What I can do is just add up my exponents. 4 plus 2, I'm going to end up with 7 to the 6th power. And there I've shown that 7 to the 6th power is equal to 7 to the 6th power. Pretty easy stuff. Again, don't get too caught up in trying to solve this and take 7 times 7 to the 3rd power and get a big giant number. All we need to do is just work with exponents, and any number here, you may want to look at that as potentially being a perfect square that you could turn into a number to the power of 2. All right, that is our first page of the study guide, and we're moving on now to number 13, which begins page 2. And you'll notice that our questions are now starting to get a little bit more thoughtful. A little more thinking has to go on, but we're almost there. So here's number 13. The point system below is used to rank teams in a hockey league. A team's record is 30 wins, 6 ties, and 20 losses. How many points does the team have? Write an expression to find the total points, then evaluate the expression and remember the label. So here's where we're getting 3 points. We need to write the expression, evaluate the expression, and label. Doesn't sound that difficult, right? So if I'm writing an expression and they have 30 wins, 6 ties, and 20 losses, and I know that they get 2, 1, and 0 points for those things, I'm just going to add up all the points they would get. So for 30 wins, we could multiply that by 2 points because they get 2 points for a win. Then I'm going to add that to the 6 times they've tied, and they would multiply that by 1 because they get 1 point every time they tie. And then this seems like unnecessary, but I'd like for everyone to do it. They get 20 losses. 20 losses times 0. They get 0 points for a loss. So what I've done here is I put my wins, my ties, and my losses all together, adding them together, and I formed an expression. Now I'm just going to solve that expression, taking it one step at a time and making my Dorito chip. So I'll do this parentheses first. 30 times 2, that's 60. So again, I'm going to rewrite this all out, and you're going to say, why are you rewriting it all out? I don't need to do that. I'm just going to say do it because it's going to avoid any potential mistakes. Next, I'm going to do the next parentheses. So I'm going to have 60 plus 6 times 1, which is 6. Next, I'm going to do the third parentheses. 60 plus 6 plus 20 times 0, that's 0. Now I'm going to add 60 plus 6, and 66 plus 0 is 66. So remember that third point comes in for the label. So the question says, how many points does the team have? 66 points. And that's all I need to do now for number 13. Let me move on now to number 14. Number 14 says, a class of 64 students is divided into equal groups for orientation. Each group should have at least 7 students, but no more than 10 students. What is the group size? So for this, it seems kind of crazy. It seems like, what am I going to do to solve this? I have 64 students. I want to take that number, 64, and try to come up with factors that go into 64. Specifically, I'm looking for a factor that goes into 64 that would be between 7 and 10 students, or 7 and 10 as a factor. So let's think about it. Does 7 go into 64? What I could do here is, maybe if I know my facts, I could think about my multiplication facts for 7, right? So let's say like 7 times 9. 7 times 9 is 63. Ooh, that's not going to work. 7 times 10, well, that's going to be 70. That's not going to work either. So 7 is out. Let me try 8. So let's try 8 times 8. 8 times 8 is 64. Ding, ding, ding. I could have a group size of 8. Just to round this all out, let's keep going and try out 9. 9 times, let's see, maybe I'll do 9 times 7. Oh, that's 63. That's not going to work. Okay, let me try 10. 10 times, I don't know, 6. That's going to equal 60. Ooh, that's not going to work either. So my group size, what is the group size? The group size is 8 students. Okay, so you're going to have a group size of 8 students. 8 groups of 8 students. Okay, that wasn't that hard when I really break that down. And all I did is kind of trial and error. Now, some of you may try to solve this in another way by just listing out all of the factors that multiply together to equal 64, like 1 times 64 and 2 times 32. And we could do that, and we would figure out then that 8 is one of those numbers. In fact, between 7, 8, 9, and 10, it's the only one that would go into 64. That's number 14. Moving along, I have number 15. I'm almost done, feeling good about it. Number 15 says you're creating identical candy bags using 36 chocolate bars and 42 peanut butter cups. What is the greatest number of bags you can fill using all the candy? This is like kind of in disguise here, but we've already learned about this. We've already done it, in fact, on this test or on this study guide, and that is the greatest common factor. If I have 36 chocolate bars and 42 peanut butter cups, I want to figure out the greatest common factor between 36 and 42, and that would be the greatest number of bags that I could fill using up all those candies. All right, so I'm going to have like maybe 1 chocolate bar and 2 peanut butter cups together in a bag, just as an example. So let me take 36 and 42, and I'm going to start by making factor trees to find the prime factorization. Later, I'm going to compare the prime factorization to find the greatest common factor. So 36 would be 6 times 6, both composite numbers, both break down into 2 times 3. So my prime factorization for 36 would be 2 times 2 times 3 times 3. Now for 42, I'm going to do 6 times 7. 7 is a prime number, but 6 is not. I know already that 6 breaks down into 2 times 3. So the prime factorization for 42 is 2 times 3 times 7. Next on my task list here, I need to find all the common primes. So there's a group of 2. Let's see, I have a 2 here, but no 2's over here. A 3 here and a 3 here. A 3, but no other 3's, and a 7, but no other 7's. So I know that I'm going to take one number from each of these, 2 times 3. Well, 2 times 3, that equals 6. That means the greatest common factor is equal to 6. So if I take it back to my question, it says, what is the greatest number of bags you can fill using all the candy? I'd say 6 bags. 6 bags is the largest amount of bags that I can fill using all the candy. All right, let's move on now to our last question, our final question. It's number 16. It says stoplight A changes color every 25 seconds and stoplight B changes color every 55 seconds. Both stoplights changed color 20 seconds ago. After how many seconds will stoplights change After how many seconds will the stoplights change color at the same time again? So for this question, we want to be thinking about least common multiple. All right, so stoplight A changes color every 25 seconds. And stoplight B, it's every 55 seconds. So I'm just going to make, I'm going to do this in 2 different ways and hopefully show you that one way might be the easiest way, because these are bigger numbers, right? Maybe this isn't going to be as easy to work with, but I could make a list of multiples. So 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300, and I'm like out of room here. I could keep on going maybe down here if I need to. Let's just see if maybe 55 will somehow, some way, get me a common multiple over here. So let's see. Now this one's going to be a little bit tougher than counting by 25s. So if you need to, you can always do some math off to the side. So 55 times 2, that's going to be 110. Oops, if I can write it, that always helps. Look up here, do I have 110? No. So let me keep going. 110 plus 55, that's the way I'm going to think of this. That would be 165. Okay, 165, not up there. 165 plus 55, that would be, yikes. See, now I'm starting to get myself confused here. I might need to do some work off to the side. I'm going to try to do this mentally. So 5 plus 5 is 10. And then 5 plus 6 is 11, plus that 1 is 12. And then this 1 would become a 2. So that's 200. See, and now I already forgot what I was doing there. So that was 12, 220. Let me double check. Yep, that looks correct. Okay, 220, it's not up here. Yikes. See, again, these bigger numbers are starting to get me. 220 plus 55, that's going to be 275. Ooh, I think I've got myself a winner. Look at this, 275 and 275. They are the only common multiples I found, and they just happen to be the least common multiples. But notice I went through this like danger zone over here. This got a little bit rocky for me because I was trying to list out multiples of these bigger numbers. In just a second, I'm going to show you another method that we could potentially use for this. But what that means is that stoplight A and B are going to change together again in 275 seconds. But it says both stoplights changed 20 seconds ago. So I would need to take 275 and subtract 20 because it already happened 20 seconds ago. So 275 minus 20 is going to leave me with 255. So I'd say my answer is in 255 seconds, both stoplights will change again at the same time. So there's my answer, and I figured it out by just listing multiples. Now, if you don't like the multiple way, I have another method for you, and that is by using prime factorization. That's right, factor trees. They're back. So let me make my factor trees here for 25. 25 is 5 times 5. And then 55, I'll say, what should I say? 5 times 11? Sure. Okay, so the prime factorization then for 25 is 5 times 5. And the prime factorization for 55 is 5 times, 11. So the way this works, and we went through this in class, and I know it's in our book examples and all that stuff. So maybe this is the method you want to use. I would look and try to figure out where the greatest amount of numbers are, if that makes sense. So I have 2 5s here and only 1 5 here. So I'm going to include both of those 5s down here for my LCM. And then over here I have an 11. It's the only 11 there, so I'm going to include that 11 as well. So what I really have is 5 times 5 times 11. Just to do a little order of operations here, that equals 25 times 11, and then 25 times 11, just to kind of show it worked out. 1 times 5 is 5, 1 times 2 is 2, placeholder 0, 1 times 5 is 5, 1 times 2 is 2. That would be 5, 7, 2, or 275. So I figured out the same answer up here, 275 seconds, 275 seconds. The big thing to know is that that spotlight has already changed 20 seconds ago, so we have to subtract that amount to get our final answer. So whether you like listing out your multiples, as I did up here, or using your prime factorization as I did down here, we're going to get the same answer. 275 seconds is when they turn together at the same time again. But we have to make sure we subtract as well to get our final answer of 255 seconds. Guys, I know this was a long video, and I hope that you can use it to help you study and prepare for our Chapter 1 test. This was our Chapter 1 study guide. Remember, everything that is covered in Chapter 1 is listed for you right here, kind of on the full screen. These are the key things that we need to know. The study guide has all the questions you're going to see on our Chapter 1 test, so take advantage of it. Use this video, skip around, go back to the questions you missed, and good luck to you as you prepare for your Chapter 1 test.